We are going to be going over 6F of the Unit 1 and 2 Cambridge Methods textbook. So in this exercise, we are focusing on graphing the factorized cubic function. So there's a couple of things that we need to understand. One is whenever we are graphing, the first part is we need to make sure that we are identifying the x-intercepts. So all cubic functions are going to have at least one intercept. Likewise, we need to identify the y-intercept as well. We need to be able to look at the relationship about what is going on with our shape. So we're going to create a sign diagram, and then we're going to use the sign diagram to sketch the graph. Now, we can use the CAS to identify the turning points, which I will go through. Um, there is other methods to do this, but we're just going to focus on the CAS for this at this stage. So we'll start off with sketching the cubic function graph of f of x is equal to x minus 2 in brackets, x plus 1 in brackets, and x plus 3 in brackets. So the step one is just identify the x-intercepts. So we know from what we've done before that to work out the x-intercepts, y is 0. Now, if y is 0, we're just using null factor law, which means if x minus 2 is equal to 0, x would be 2. If x plus 1 is equal to 0, then x will be negative 1. And if x plus 3 is equal to 0, then x will be negative 3. We're now then just going to look at identifying the y-intercept. So any y-intercept is when x equals 0. So in our equation, I'm just making x is 0. 0 take away 2, 0 plus 1, and 0 plus 3. So I'm really just going, okay, well, I'm just timesing negative 2 by 1 by 3. And that gives me negative 6. Now, this is where we create a sign diagram for our final step before we graph. So a sign diagram is we start off with our roots, our x-intercepts, and I place them on a line. So this is where we need to pick a number on the outside. So for instance, if this is negative 3, I'm going to say I've got negative 4. So this is, I'll erase this each time. So if we've got negative 4, I'll just write negative 4 there. That means negative 4 take away 2, that gives me a negative. Negative 4 plus 1 is negative, and negative 4 plus 3 is negative. So negative times a negative is a positive, positive times a negative is a negative. So that means I'm going to have my graph starting down here. I'll erase that part now. So when x is less than negative 3, y has to be negative. Then we go to the next part. I pick a number between negative 3 and negative 1, so I'll pick negative 2. Negative 2 take away 2 is negative. Negative 2 plus 1 is negative, and negative 2 plus 3 is positive. So negative times a negative is a positive, positive times a positive is positive. So that means my graph will be positive area when x is between negative 3 and negative 1. Erase. Okay, let's continue. So now let's look at a number between negative 1 and 2, and 0 is probably the easiest. So 0 take away negative 2 is negative. 0 plus 1 is positive. 0 plus 3 is positive. And that gives me a negative. A positive is a positive, and positive and negative is a negative. So that means between negative 1 and 2, we go back into the negative area. And then finally, I need a number bigger than 2, so I'll just do 3. 3 take away 2 is positive. 3 plus 1 is positive. 3 plus 3 is positive. So I'm not caring about the number, I'm just caring about is it positive or is it negative? So that means when x is greater than 2, y must be positive. And you probably also notice I'm picking numbers that are easy to do in my head. Okay, so now all I'm going to do is put all my points that I know onto the Cartesian plane. So I've got my x-intercepts at 2, -1 and -3, and I've got my y value of -6. So when I put my graph on, I'm starting in the negative. When it gets to -3, it goes positive. Then it goes back down to my intercept at -1, and then it's going into the negatives and back into the positive when it gets to 2. So it's identical to my sine diagram. The only part I haven't been able to put on is my local max and my local min. So if I wanted to do that, that's where I use the class pad. So remember, if we forget how to get to that page, we go menu and we go graph and table, and then I'm just typing in my equation. So I've got x minus 2, x plus 1, and x plus 3. So I've graphed it. Now this is where we can go endless, gsolve, and I could find my y-intercept. I could find my root that I've already got. And I can also go, I want to find my maximum. So this is where it tells me that local maximum that I have, which is when x is -2.11, y is 4.06. Likewise, if I go endless, gsolve, and min, it's telling me that local min is 0.78 and my y is -8.2088. The only thing I haven't done is just make sure you label each of these 4 points plus the local min and max as a coordinate. The next question, f of x is equal to -2x in brackets x minus 4 in brackets x plus 1. So the first thing we're going to do is identify the x-intercept. So to find the x-intercepts, we know y equals 0. As soon as I've done that, we are using our understanding of null factor law. When one of these is 0, the whole thing's 0. So that gives me -2x equals 0, x minus 4 equals 0, and x plus 1 equals 0. Now from here, I just need to solve. So how do I make x, how do I get x by itself? Well, x will be 0. If I get x by itself, x will be 4. And if I get x by itself here, x must be -1. So I've got my 3 intercepts. Identifying the y-intercept is the next step. Now, when identifying the y-intercept, the first thing I need to think about is x equals 0. So I substitute that into my equation. So now I've got x equals 0 in there. I just solve it. -2 times 0. Well, now I can see I'm just timesing by 0 here, which means 0. And we kind of knew that already because it said an intercept for x was at 0. So which obviously means when x is 0, y is 0 here. Next part is creating a sine diagram. So I put in my my 3 points, and they are my roots. I then pick a number between them. So my first number I'm going to pick is -2. So I'll just write that down. -2 times -2 is positive. -2 take away 4 is negative. -2 plus 1 is negative. So that tells me that I've got a negative is a positive, positive and a positive is a positive. So it's in the positive area. Okay, let's go to the next part. So now we want to find out what is it positive or negative between -1 and 0. So let's pick a -1/2. Negative times negative, it will be a positive here. negative a half, take away 4 is negative, and negative a half plus 1 equals positive. So straight away there, I've got a positive and a positive is a positive, and positive and a negative is a negative. So I'm in the negative area between -1 and 0. I then need to pick a number between 0 and 4. I'm just going to pick 1, nice and simple. So if I pick 1, 1 times -2 is negative. 1 take away 4 is a negative. And 1 plus 1 is a positive. So that gives me a negative is a positive, positive and a positive is a positive. So I'm in the positive area. And then the final one is I'm wanting to look at if when x is greater than 4. So I need to pick a number. I'll just pick 5. I don't want it to be a massive number. So 5 times -2 will give me a negative. 5 take away 4 gives me a positive, and 5 plus 1 equals positive. So that gives me a positive, positive is a positive, and a negative is a negative. So I'm in the negative area. I just need to put down my 3 points because the y-intercept here is in the origin. Based on the behavior, I know it's going to start in the positive area. I will get my laser pointer. So it'll start in the positive area. As soon as it gets to my first intercept, it goes into the negative. As soon as it gets to the second intercept, it goes into the positive, and the third intercept, it goes into the negative. Just make sure we look at those 3 points and label them as a coordinate. Second, I also encourage you to use your class pad to find the local min and max. So in this case, I'm just going to graph it. I've got -2x, x minus 4, and x plus 1. Okay, so now I've got my graph. The only thing is that I can't see it, so I'm just going to change it. So I should have said, if I go to this button where it's got the 4 arrows, I click on it. I just type in 20. I still can't see it, so I'll change it again. Let's make it y is 40. Okay, now I can see my local max. So if I wanted to check what those points are, I'll go to endless, I'll go down to gsolve and go max, and it tells me when x is 2.57, my y value is 26.25. Likewise, if I go to gsolve and I go down to min, my local min when x is negative 0.527, my y is negative 2.256902. Okay, so next question, we've got sketching cubic function graphs with one x-axis intercept. So let's look at this question. We've got f of x is equal to x minus 2, and then we've got x squared plus 4x plus 8 in brackets. So if we wanted to identify the x-intercepts, we need to make y equals 0, and we've got 2 options. We can look at the first part, x minus 2 equals 0. That gives us x equals to 2. Is a root. The second one is we've got a is quadratic. So just to check, because we already been told that it's one x-axis intercept, I'm going to use the part of the quadratic formula to work out whether I am able to factorize it. So I'll use b squared minus 4ac. b is 4, a is 1, and c is 8. 4 squared is 16. 4 times 8 is 32. So I'm going to get a negative, which is the reason why there are no further linear factors. So that means I just need to identify the y-intercept. And to do that, I just have x equals 0. So that is really just going to give me 8 times -2 equals -16. I will use the CAST calculator to identify the turning points. So here's a list of things that you can do to be able to do it. I'm just going to do it anyway and show you. So, but we will get a max and minimum value, and then we can plot it. Now, what you can see here is we've only got one intercept up here, whereas everything else is below the x-axis. So again, I'll show you on the class pad. Let's get it up. So on the class pad, I'm just going to delete that. If I type in my function, so I've got x take away 2 and x to the power of 2 plus 4x plus 8. And again, I will just graph that. So what we can see at the moment is it's not showing us everything because of our graph is below the x-axis mostly. I'm just going to change it. So I'm just going to go y is -40 and I'll make that 5. So this is why on the calculator you need to know how to adjust. So now I can see it quite clearly. So again, if I wanted to find out all the points, I go analyst, I go G-solve. If I want a y-intercept, it will tell me what I've got, 0 and -16. If I would like the root, 2 and 0. And the pieces that I'm missing is the local max, which is here, -1.3 and -14.81. And finally, if I go to G-solve and do the minimum, I'm going to have this right here at 0 and -16.